Okay, here is the final part to our exam review. You've had a couple parts. I think what did we start out with? Chapter 6, you had Chapter 7, 8 was rather short, and now 9 and 10 are combined. Okay? Sorry, 9 and 4, not 10. So our first part, so this is the most recent test you took, not the whole mean, median, mode stuff, but the other. So the idea is we're going to rewrite the function into the other two important forms. Those are our three forms. We had some notes discussing this, and I'm just refreshing your memory because I don't have my flip book. Standard form, to get to factored form, we're going to factor. From standard form to vertex form, we're going to complete the square. And if I want to go from those forms into standard form, you're going to be doing a lot of multiplying and then combining like terms. So let's start with standard form. I'm going to take this, I'm going to write it over here. And I'm going to factor. So factoring means we're going to make the x. And I need factors of, this is hard to do when you are holding the camera. Sorry about the messiness. Factors of 20 that will get me to 8 are going to be 10 and 2. And I'm going to make, it's hard to see that, sorry. I'm going to need to make that 2 negative. So I'm going to rewrite it now as x squared plus 10x plus negative 2x plus negative 20. Again, we just replace this version of 8x with that version of 8x. Then you can group them. And then I'm going to take a x out of the first set, and x times what gives me x squared is x. X times what gives me 10x, that's 10. And the next set, we're going to have our matching parentheses. So what times x gives me negative 2x, that's negative 2. And negative 2 times 10 is the negative 20. And then you can write in parentheses. So x minus 2 and x plus 10. And remember, factored form gives you the x-intercepts. So my x-intercepts, I'm going to write them as a coordinate, are 2, 0 and negative 10, 0. Remember, we're just asking ourselves what makes it 0. In standard form, our key point is the y-intercept. As a point, I'd write that as 0, negative 20. Remember, it's just the plain constant at the end. And in your flip book, this was in the top left. And so now vertex form. I'm going to complete the square. So I'm going to group my x's. It's ready to go, though, because it is x squared. And there's that minus 20. I'm going to go ahead and add the opposite on that. And remember, we're about to add a number, so I'm going to subtract a number. Take this number, cut it in half. We're going to square it and add 16. And it really is just worth 16. There's not a number that's affecting this, so it'll be 16 here. I'm going to add the opposite on this. The numbers on the on the outside, now that I add them, is negative 36. Here's my parentheses squared, and remember it's x plus your cut in half number. And so in vertex form, we get the vertex. Remember, always do the opposite here, negative 4, and then as is negative 36. Okay, next one. So this is in vertex form. So to go from vertex form to standard form, and then I'll have to go from standard form to factored form, I'm just going to do a multiplying. So that x plus 1 squared really means that there are 2 of those. And we kind of agreed as a class that that's where we would start, is just doing this multiplying here. So members, neighbors, visiting neighbors, there's x squared and 1x. And then the other neighbor visits, 1x and 1. Don't add those. Sometimes we're adding those. There's the minus 4. And then we'll combine our like terms. So x squared plus 2x. And then if you want to add the opposite, there's your negative 3. And there's your standard form. And I'm going to take this over here and I'm going to factor it. So I'm going to make my x. I need the factors of negative 3. It's just the side because the paper's curling up. That give me 2x. And so there's only one set of factors of 3, 1 and 3. And to get to 2, I'm going to have to make that negative. So I'm going to rewrite it now. Instead of 2x like that, 2x is going to look like that. So x squared minus 1x plus 3x plus 3. And then you can group them. I'm sorry, plus negative 3. So I'm going to group them. And what can I take out of both of those? I can take an x out. And I'm left with x times x giving me x squared. There's the minus sign, and x times 1 is 1x. And then here's the x minus 1. So what can I take out? What times x is 3x is 3, and 3 minus the 1 is the negative 3. All right, I have to do a little pausing. So anyway, I'm ready to make my parentheses. X plus 3 and x minus 1. So now let's go for those key points. Again, in factored form, you're going to get your x-intercepts. So what makes them 0 is negative 3 and 0 and 1 and 0. And again, the 0 here is why they're called zeros. In standard form, our y-intercept is our key point. Oops, so 0, negative 3. And then vertex form, our key point is the vertex, negative 1, and that you should look at as negative 4. Okay, final one. This time we are in factored form. So we're going to have to go from factored form to standard form. We're going to have to multiply, and then from there we can complete the square and get to vertex form. So again, we agreed that we were just going to always multiply these parentheses. So this is going to be neighbors visiting neighbors. So I'm going to have x squared minus 3x, and then 1x is going to visit. I'm going to get 1x and minus 3 because I'm multiplying. Don't add those. I'm going to combine my like terms of these, maybe add the opposite here, and you get negative 2x. I'm going to add the opposite there. And then what still has to multiply, because there's 3 things, I've only multiplied 2 of them, is going to be the 2. And now the 2 is going to meet the neighbors, and we're going to get 2x squared plus negative 2x plus negative 3. So this is my standard form answer. And I'm going to take this and I'm going to complete the square. So I'm going to rewrite it over here. So 2x squared plus negative 2x plus negative 3. To complete the square, I need to group my x's, but when I group these x's, I'm going to pull the 2 out of here, which means I need to factor a 2 out of there. So that gives me a negative 1x. So 2 times this is this, 2 times negative 1 is that. There's my blank for completing the square. And there's my subtraction for when I'm, sorry. All right, so I'm going to take this, and I'm going to cut it in half, and then I'm going to square it. So negative 0.5 squared on my calculator is 0.25. So I'm going to write that there, but when I bring this 2 back in, 2 times 0.25 is a half. So it's really going to be a half, and you can use your calculator for that. That's supposed to be my 0.5. So anyway, I'm going to write this below. Sorry, I know that was really zoomed in. 2, and then x plus my cut in half number. Whoops. And then if you have this minus 0.5 here and you add the opposite, I'm going to get negative 8, or sorry, negative 3 and negative half when you add them is negative 3.5. Okay, sorry, that was negative 0.5. And again, I can't hold the paper down, so it slides around. So my key points, let's start here. I'm going to take the opposite, so 0.5. And that one as is, negative 3.5. There's my vertex. In my standard form, I'm going to get my y-intercept. And in my factored form, what makes these 0? I'll get my y-intercept. So negative 1, 0. And, sorry, 3, 0. Okay? All right, moving on. So what I did here is I went ahead and set up my graphs. I think this is like the top right of your flip book. And we discussed a couple ways to graph. So I went ahead and picked the way that we did in our flip book. And we talked about some points that we could pick for x. Okay, that would fit on the graph. Those all fit in here. And when we square them, the points still fit on the graph. So I just copied them all here. I accidentally put the x, y on the wrong side. So the first thing I'm going to do is talk about the different transformations. So remember the number in front, this is going to stretch it when it's bigger than when it stretches it. I'm going to take the opposite of the number in here, and that's 4. So it's going to go right 4. The inside number is left or right. And then that minus 3, this outside number here, this is my down or up number, but it's going to be down because it's subtracting. So here what's going to happen is this negative, kind of like placed where the 2 is, that's going to flip it. And again, inside, Just like we took the opposite of here, we're going to take the opposite of what's in here, -4, which means it's going to go left 4. And on this one, there is no number here. It won't stretch or compress or flip, but this number, take the opposite, is going to make it go left 1, and then this will make it go down 1. So the first thing we do is we take the A and we apply it to our table. So I'm going to take all of these y values and just multiply them all by 2. So I'm going to get 18 and 8 and 2 and 0 and 2 and 8 and 18. Graph these. The 9 18s are not going to fit on here, okay? So I'm going to start with 4 8, 1 2, 0 0, or I'm sorry, it's -1 2, 1 2, and the other 4 8, okay? And now I'm going to take these points and they're all going to go right 4 and down 3. So each point just goes right 4, down 3, right 4, down 3, and right 4, down 3. And you're going to see your graph a little more stretched out, sorry, and it's gone to the right and down. So for this one, I'm going to take my y's and I'm going to make them all turn into the opposite or multiply them by -1. So you're going to see your U shape flip upside down. So I'm going to graph those first. So here's -3, -9. You've got a dog in the background, -2, -4. Okay, then we've got our -1, -1, 0 0, 1 -1. This is where I am right now. 2 -4, and then the 3 -9. So again, when we change our y values, the old y's go away. And now I'm going to take all of these and just move them left 4. So it's going to stay the same shape. It didn't stretch or compress, but everything's going to go flip upside down. And I'm just counting them all to the left 4. And then go left 4. And so again, same shape, just flipped upside down and to the left. All right, next one. So this one is not going to stretch or compress, so I don't have to do this extra set of y's. There's no a. So instead, I'm just going to graph these. And again, I've graphed them a lot, so I know where they go pretty fast. Okay. And then from there, I'm going to take them all, go left 1 and down 1. And then you've got your U. Sorry, they should have gone through the X's. They didn't. Again, one-handed. All right, let's talk about this last one, and then I'm going to take a little break and finish this up. We've got our two graphs here. So f of x is the before, g of x is the after, and we have to talk about what happened to f of x to get to g of x. So the point that's going to help tell us that is going to be the vertex. So let's start out with the more obvious. It's from here to get to here. We're going left 4. So 1, 2, 3, 4, and then we're going down 3. 1, 2, 1, 2, 3. What might not be as obvious is this whole A, and we added this in the bottom right of our flip book. If you go over 1, see how many times you have to go up 1, and that's what your A is. So after I go over 1, if I go up 1, I get to my graph. Here, when I go over 1, I still go up 1. So that A is 1. So it didn't stretch or compress. Had I gone up 2 spots, then my A would be 2, and then I would have said it stretched, but that's all that happens here. Okay? All right, we're on our last page. So on this page we're solving, this is going back to the mile marker, and if you have your flip book, you want to look at the back, and we're talking about that there's more than one type of x, like these two, or just one type of x. So let's go to the one type of x, and the fact that we're going to use what's called the square root method, and that we are going to work backwards in these order of operations. And when you do this on the final, make sure you write those down. So remember, x wants its own room. To get x by itself, I'm going to move my addition and subtraction first. I'm going to add 15 to the other side. And now I'm going to move my multiplication division. So what a lot of us are making the mistake on is we want to get rid of that square root first. You need to move the fact that the 3 is multiplying here. So I'm going to get rid of that. I'm going to divide by 3. And I'm going to get x squared equals 5. And now to get rid of the exponent, I'm going to use the square root. So I'm going to square root this side, and I'm going to square root this side. So when you take the square root of 5, you get some decimal. I guess you can put the decimal down if you want. You could just leave it as the square root of 5. So you could do this. You could get the decimal, because 5 doesn't have any factors that have a perfect square root. And just remember, there's the negative version, but the negative stays outside the square root here. Okay? Now on the others, since there's more than one type of x, what I'm going to start with is factoring. So I'm looking for factors of 15, x squared. That'll get me to -2. So factors of 15 that get me to 2 are going to be 5 and 3. And to get that -2, I'm going to have to make the 5 negative. So now I can rewrite it. So x squared, and instead of that minus 2x, rewrite that minus 2x, like that. And now I can group them. And then I go for the greatest common factor. So out of both of those, I can take an x, and I'm left with x minus 5, which again is the matching set of parentheses. And again, another thing is we're just getting it from standard form into factored form. But what times x gives me 3x is 3, and then you've got your parentheses, and we seem to be good with the factoring. But a few of you, again, you're still stopping here, and you're not asking yourself what makes a 0. You're not taking that last step. These are pretty simple to solve. -3 will make that 0, and 5 will make that 0, and then those are, one, they're your x-intercepts, but they're also your solution to the equation. So on this one, I'm going to try to factor. And I'm going to look for factors of -10 that get me to 1. And there are no factors of 10. Here are the factors of 10. Neither of these get me to 1. So that means you're sad that you can't factor. So we're going to sing a little song and do the quadratic formula. So we're going to go through A is 2, B is -1. There's like if you add the opposite, -1, and C is -5. And remember, x equals opposite b plus or minus square root. Then I'm going to take b squared without your calculator. -1 times -1 is 1. It's not 2. It's not -2. It's not -1. And then minus 4 and a and c. And it's all over 2a. So 2 times 2 is 4. And then you can turn on your calculator if you need to and do 1 minus 4 times 2 times -5. If you just start, for instance, without the calculator, multiply. So here I get -8. -8 times -5 is 40, and then you add that 1. Your calculator will come up with 41. So then you could look for factors of 41 that have a perfect square root, and there aren't any. So this is a great answer. You could leave it like this. Otherwise, you can go to your calculator and do 1 plus the square root of 42, hit enter, and then divide by a. And you got that version, 7.48. And then you can do 1 minus the square root of 42. Oops, sorry. 1 minus the square root of 42. And then divide by 4, and there's your other answer, so -1.37. Okay? So, all right, final part for this part of the review for the chapter 9. Chapter 9, chapter 10. Now we're going to write the equation. So this is on the right side of your flip book, like those two center ones, and you just have to look at what you're given. Since I'm given the vertex and another point, you're going to use this one. And remember, to write the equation, we'll need A, opposite of H, and opposite of K. So we already have the opposite of H and K here. But we're going to use this point and this point, fill them into these spots, and we'll then be able to figure out what A is. So to figure out what A is, I'm going to take, this is X, this is Y, this is not, that's H, and that's K. So I'm going to do X plus the opposite of that, square it, I'm just filling in here, plus K, and that's going to equal Y, so that's the 7. And then I go here, that's 3. 3 squared is 9, so I'm going to have 9a. And now to get a by itself, it's its own room, I'm going to subtract the 4 over. And then I'm going to divide by 9. And that's going to give me 3 9s, or 1/3. It doesn't matter. You could even put the decimal version. But anyway, now that I've got A, I'm going to use the 1/3. That's going to go in. Leave X as X, plus, again, do the opposite of that, plus K equals Y. And then this is the equation. You've written the equation. So if we wanted to graph it, you know, we could make our T-chart. We'd multiply everything by 1/3 and then move things left 1 and up 4. Also, you can see the vertex is -1, 4. I mean, all these different things you can do. So on the last one, with the x-intercepts, you use the flip below it if you put it in the same spot as mine. So this is an x, and that's an x. I'm sorry, that's P, and that's Q. And then this is the other point. This is the X and Y. So we've got all of this stuff, but for the equation, we need A and this and this. So here goes A. X is going to be the 1. I'm going to add the opposite of this number. And it multiplies, remember, and there X comes again. And I'm going to add the opposite of this number. And then I'm going to put my Y in. All right, so now I'm multiplying, so I'm going to add these up. That's -4. I'm going to add those up. That's -1. And remember, this is all multiplication here. Some of us want to add here, but I'm going to multiply those. That's 4. So it's 4A equaling this. And now to get A by itself, these are multiplying, so I'm going to undo that with the division. And now I've got my A. And so now I can write the equation. So I'm going to put right here. So put A back in. You could do the decimal as well. Leave X as X. We're going to do the opposite of P, and then X again, and the opposite of Q, so -2, and it's going to equal Y. And this is your answer for number 12. All right, last question for this section. So suppose you're asked to find the max or min of a quadratic function. So what point on the graph are you being asked to find? Well, that's the vertex. And what form would you want to have your equation in so that you could find it? You would want it in vertex form. And so now it says you've got the height of a soccer ball, and T is measured in seconds, so what's the maximum height? One thing is you could just put this in your calculator and then use your second trace button to find that max or min. This is upside down, so it's going to be a max, but I'm going to complete the square. So I grouped my T's together. I did take a -16 out. I took a -16 out of there. That left me with -2. And I put my 2 on the other side. There's the plus blank and the minus blank. And I'm going to take this, cut it in half. I'm going to square it. That's 1. And even though I'm writing 1 down, remember, it's really worth -16. So here I'm going to add the opposite, and you're going to see that that amount is really worth 18. And then you're going to have your parentheses squared and T instead of X, and your cut in half number, and then don't forget that -16. So now that it's in vertex form, what's the maximum height? Well, our vertex is this, sorry, opposite of that, so 118. And remember, X is your time, so that's your height. So what's the maximum height? It's 18 feet. And when does the soccer ball hit the ground? So basically, when does this equal 0? Well, since there's just one type of T, what I can do is get T its own room. So let's write it over here. All right, so we're having T get its own room. So if it helps, write those order of operations backwards. And the first thing I'm going to move is the addition subtraction. I'm going to subtract the 18 to the other side. Next, I'm going to move my multiplication division. The -16 is multiplying, so I'm going to divide by -16. Yeah, I saw a little bit of room here. Those are my parentheses. So if you take -18 and divide it by -16, you're going to get this on your calculator. Now I'm going to get rid of the exponent. So I'm going to square root both sides. So T plus -1, and then you take the square root. Sorry, I know that's bad handwriting. I don't have anything to hold the paper down with. I'm going to get a positive 1.06, And don't forget there's a negative 1.06. And now I'm going to have two problems. T plus negative 1 with the positive version, and t plus negative 1 with the negative version. So here, just real quick, if I add 1 to this, I'm still going to have a negative number. And time can't be negative, so I won't take that answer. But here, when I add 1, I'm going to get 2.06. So this is my actually only answer because time can't be negative. All right, we're going to finish up this last page. Okay, so describe the shape of each of the following graphs or box. Remember, shape is it symmetric? Is it skewed left? Is it skewed right? Maybe you could talk about the mode. So this is symmetric. And this is, I can't remember what color it is, but it says shape. And it's one mode, so it's unimodal. This is also, although it's not perfect, it's more symmetric than it is anything else. But it's still just one mode. Even though there's two high points, one is a little bit higher. And then this is skewed right. And it's unimodal. There's one mode. Okay? So this graph is symmetric. There is no mode. This one is skewed left and one mode. So you could say unimodal as well. This one is symmetric. It's a little different of a symmetric though than this one. Here the middle is the high point and here the middle is the low point. So there are still, those look to be about the same, two modes, so bimodal. This one is skewed right. We can't tell the mode on a box and whisker plot unless we knew the actual data that they used to get that. This is skewed left. And this one is symmetric. All right, so describe the shape of the following data without graphing it. So the mean was 64%, but the median was 70%. So if you put your mean, your median, and your mode, and you've got your mean is 64 and your mode is 70, since it's pointing to the left, this would mean that it's skewed left. So the ages of all the students at EHS was recorded and a histogram was made. Probably the ages, you know, since you've got your low end of high school, which might be 14, and then you got your upper age of 18, and all the classes are pretty even, I would say that this graph is symmetric. And probably with no mode. Okay. The median price of a home in Aurora is $255, but the average price is $280. So again, mean, median, and mode. The median is the $255. Yeah, I'm going to drop the zeros off the end. And the average, that's the mean, is $280. So when I do this, it's pointing to the left. That means it's going to be skewed left. And a box plot that was symmetric had a very large value added to it. So if I had my box plot, you know, pretty symmetric, and then all of a sudden I add another point very large at the end, my max would go up, then it's going to be skewed right. And that's it. We have made all the videos, no more to watch, and I will see you guys soon.